Hi everyone, this is Anshwan Sebi. We'll be working on lab number 2, which is static characteristics of semiconductor diodes. This is for ECE 3100. Okay, this is a pre-lab. This is what you have to do. Gonna start from this part. Well, as you know, today we're gonna work with the diode. Diode is that device which allows the current flow through only one direction, and the diode will act as an open circuit as long as the voltage or the voltage forward voltage is less than pretty much 0.67 or so in this kind of diode, which is the N4001. And when we hit that forward voltage, the diode will act as a short circuit. So we're gonna follow these steps here. We're gonna start with this circuit A, the forward characteristics, and we need to change the voltage here, the Vs, which is V source, which is this source here, power supply, to get these values on Vd, which is 0.1, 0.2, 0.3, what we're gonna read from this multimeter. So here gonna be Vd, this is the Vs, okay? And we need the current through the diode, the ID as well. We have to connect a multimeter here. You know, in order to measure the current in the lab, the multimeter's gotta be part of the circuit. What does that mean? That means the current just goes through, comes from the circuit, then goes to the positive part, which is this part of the multimeter, and the negative part will goes here, connected to here. So the circuit here will be open and connected to the positive part of the emitter, and the negative part of the emitter goes to here. So this one will be part of the circuit, but because it's kind of hard, and for the TAs, I mentioned this for the other TAs, you don't have to do this, because we will have some problem with the equipment, and we had it before. So the easiest way, we can connect the voltmeter across the diode, right? That will hit two goals in the same time, because we need to measure the current when the Vd 0.2, then measure the current or ID current, the current through the diode when the Vd is 0.2, and then when the Vd 0.3, and so on. So if we connect the voltmeter here, right, so we can get those, and we know Vs with the power supply, because we are changing. So the only thing missing will be ID. ID is, we can use voltage Kirchhoff law, right? So we're going to be Vs minus Vd. We will have Vr, right? This is Kirchhoff voltage law, right? And if we have Vr, we have the resistor value, we can get the IR, the current through the resistor, right? And if you see, this is a series connection, right? They are connected in series, the resistor with the diode. So the current through the resistor will be the same as the current through the diode, right? So in our case, we're not gonna connect the emitter here. So it's gonna be this side of the resistor connected directly to here, but we're gonna connect voltmeter across the diode. Again, we're gonna use Vs minus Vd to get Vr. Vr over 100 ohm, we will get the IR, which is the same as ID. So in this case, we need to form a table of 3 columns. The first column to the left will be Vs, the voltage that we are getting from this power supply. The second column will be Vd, the voltage we are getting from here. The third column will be ID. ID will be Vs minus Vd over 100. Okay, so we're gonna stop till when we get 12 milliamp. Don't worry about this part. This part is not correct. Should be 12 milliamp, not 120 milliamp. So this will be corrected. This is the correct one. This is not. So from 0 milliamp, so the ID should be from 0 milliamp to 12 milliamp, not to 120 milliamp. In this case, I'm not gonna provide you, I'm talking to the students, online students, I'm not gonna provide you with a table of that, like what I did in the previous lab 01, because we're gonna emulate or pretend that we are in the lab. When you are in the lab, nobody provides you with the data as written. Everything is showing in the camera, the values is very clear. So I'm going to change the values of the Vs, the voltage, and you're going to read the Vd from here, and you do your calculation to fill the table. Okay? So let's stop this recording because I don't want to be large in size. Then I'm going to start the experiment after that.